So in this video, we're going to talk about chemical equilibrium. All right. So what is chemical equilibrium? All right. So let's imagine this. All right. So let's just say we have this reaction here where we have acetic acid, CH3COH, reacts with ethyl alcohol, which is HOCH2CH3. All right. Now, when you mix these two together, what you're going to have is you're going to make ethyl acetate, CH3COCH2CH3, and water. Okay, so you have acetic acid with ethyl alcohol, make ethyl acetate and water. So now in the very beginning of this reaction, right, all you're really going to have is your reactants. Okay, but then when you mix those reactants together, what you will quickly notice is that the amount of reactants you're going to have will start to decrease. All right. And you're producing products. All right. But then what you start to notice over a period of time as the reaction continues to take place is that then the opposite start to take place. All right. That these products here, water and ethyl acetate, when they collide with sufficient amount of energy and the right orientation, all right, it will start to make acetic acid and ethyl alcohol. What is going on? Well, most reactions, actually a lot of chemical reactions, pretty much happens this way, where that originally, all right, there is a forward reaction, all right, because all you really have is just these two reactants colliding with each other, correct orientation and the right amount of energy, sufficient amount of energy or activation energy, and then you are making these products here. But then when you have just enough concentration of the products, when they collide with one another, amongst this mixed with enough energy and the right orientation, then what we will say, then the reverse reaction will take place. Now, what you're going to find is that these two reactions, the forward reaction and the reverse reaction, is happening at the same time. All right. And it's specifically when both reactions occur until the concentrations of reactants and products undergo no further change is when you reach equilibrium. Okay? So, now, equilibrium doesn't mean that the concentrations of the reactants and the products are the same. No, it just means that they have both reached a concentration that as the reaction continues to the reverse and the forward reaction continues to take place, the overall concentrations of reactants and products are no longer changing. All right. And so what I mean by that, originally there's a huge concentration of the reactants and it will decrease as the reactions taking place, as it's creating products. At some point when the products are large enough, it will start reacting, all right, to create the reactants, all right. And then so at some point when the rate of your forward reaction is equal to the rate of, I wrote rater, I don't know why I did that, but the rate of, and I did the same thing over here too, crazy, rate of the reverse reaction, all right, when they're equal to one another, this is when you have equilibrium, all right. So, and this type of equilibrium is what we call dynamic equilibrium. simply because meaning that the reaction never really stops. All right. I mean, to us, it seemed like it has because then we don't see a change in the concentrations of either the reactants or the products. But the reaction is always constantly going. Just what happens is it's happening at the same rate. So there's no net change. All right. So as quickly as the reactants are becoming products, it's just as quickly as the products are becoming reactants. All right. Now there might be different concentrations of the both, and that's fine. It doesn't matter. But ultimately, the rates are the same. And so we could actually kind of graph this out, and you could see this graphically, right? Where you have, I prefer white. Where you have the time of the reaction versus the reaction rate. Okay, so if you consider the rate in which this is the rate of the reverse reaction, all right, and this is the rate of the forward reaction. So that simply means when you're thinking about this, right, I'm just going to kind of make this up. All right, so here's the forward reaction. The very beginning, the forward reaction is very high, and then it slows down over the time of the reaction. All right, and then it stabilizes. Same way, if you look at the reverse reaction, all right, it's very low in the beginning, very low. The products don't make reactants as much in the very beginning, but as a period of time, it increases, and then it stabilizes right around the same place where the forward reaction stabilizes. And so this area here, it says that we are at equilibrium. All right, and so that's kind of the key thing here. Now remember, this equilibrium is very active, is very dynamic. Okay, simply means that the reaction is always still taking place, but the rate in which they are changing are exactly the same. So looking at it from our point of view, it just seems like the reaction has stopped. But if you were able to zoom in at the very reactions, you could see the molecules. You could definitely see that the reaction is still keeps on going over and over. And I mean, pretty much until whenever. All right. So that's equilibrium.